Alright, so we've got our equation punched in here. I hit the y equals button, 7 minus 3x. And just a reminder, if I hit graph right here, something like this showed up, and that's not very appropriate for what I want. So we really, before we hit graph, always want to be going into the window button here. And you're going to hear me say this a lot, but if you're not really sure what to go with, start with negative 10 to 10. Alright, always a good place to start. We can adjust from there. Negative 10 to 10 for x, and negative 10 to 10 for your y values. And now if we go back in here and graph, everything does show up nice and neat. One nice feature that I don't think gets used enough is the zoom fit option, which if we go into zoom, which was right here, and go down to number 10, 0 right here, zoom fit, hitting that one, okay, is going to resize it so it gets as much as possible on the screen. Now, appropriate for this one, maybe not as much because we want to be zoomed in more on the intercepts here, right? But this one fits as much as possible on our screen, so that's helpful. What if we wanted to zoom right in on here? So the other really helpful zoom option is zoom box, which is the very first one, number 1. And what that does is you can see a little flashing cursor right here. We're going to move this up and over, and I'm really interested in the intercept. So I want to be above and to the left by just a little bit. I hit enter to start, and now I'm going to go down and over, and you can see it's creating a box here, and it's going to zoom into whatever I want for this box. When I hit enter again, it's done, and now it zooms right in on these parts that we're interested in. Okay, so just a reminder, I think a lot of you have seen these before, but zoom fit and zoom box, the ones we're going to be using most. Alright, so let's come back here, sketch the graph. We've just done that. Intercepts are really the important things here. Okay, but it does look like this coming down. So just a quick sketch of that graph. The important points here were 7, and down here we can flip back if we need to. And right here, let's hit the trace button to put ourselves on the curve. And where are we going to cross the y-axis? Looks like about 2.3 right in there. Okay, we could figure it out exactly, but let me erase this. 1, 2, 3. Looks like it's going to cross somewhere right about in here. All right, if we're just going for a quick, dirty sketch, we can do something like that. So try the same thing with exercise 15. All right, how about x squared minus 2? All right, so we do have a parabola here with an x squared, so we can figure that out. Let's do this one with a t-table here. Another option that we have for us. So x and y. All right, so t-table, I always like to start with negative 3, negative 2, negative 1, 0, 1, 2, and 3 for my x values. All right, so and then I like to start in the middle. If I plug in 0, 0 squared minus 2, I get negative 2. How about if I plug in 1? 1 squared is 1, minus 2 is negative 1. How about 2? 2 squared is 4, minus 2 is 2. How about 3? 3 squared is 9, minus 2 is 7. All right, so we'll get the other side here. How about negative 1 squared? That's 1, minus 2 is negative 1. We can start to see that there's going to be some symmetry here. Negative 1 matched with the 1, right? If I plug in negative 2 squared, that's 4. 4 minus 2 is 2 again. All right, so you can fill that one in just because we know the symmetry here. So a quick sketch here. We're going to be at 0, negative 2. That's our bottom. And then we're moving up from there. We have points at 1, negative 1, and then we have points at 2, 2, and 3, and 7. 3, 4, 5, 6, 7. The parabola is becoming exponentially steeper. And there's a nice parabolic sketch. Your job is to do exercise 17. All right, we mentioned intercepts quickly before. Let's go ahead and do these again. And so this should be a reminder from Algebra 1 as well. To find x-intercepts, we're going to make y 0. And to find y-intercepts, we're going to let x be 0. So here's a couple examples of different intercepts. You can see on the first one there, no x-intercepts, doesn't cross the x-axis, but one y-intercept. There's one with 3 x-intercepts and 1 y-intercept, and that y-intercept's at the origin. 1 x-intercept, 2 y-intercepts, and finally no intercepts at all on that circle. So different options for intercepts. All right, let's go ahead and find our intercepts here. So y equals x cubed minus 4x. I'm going to find the x and y intercepts. So I'm going to start with the easy one. The easy one being make x 0. Alright, you can see that comes in pretty easily. 0 cubed is 0. 4 times 0 is 0. We're just going to get 0. Alright, so if x equals 0, y equals 0, so one of our intercepts is 0, 0. Now we have to do one that's a little trickier, and that's going to be making y 0. So y becomes 0. Our job is to figure out x. Alright, so we can factor an x out. We're left with x squared minus 4. We can then factor x squared minus 4 into x plus 2 and x minus 2. And so now we have 3 answers here. X equals 0 from this one, x equals negative 2 from this one, and x equals positive 2 here. So if y equals 0, x equals 0, negative 2, or 2. So that gives us these intercepts 0, 0, negative 2, 0, and 2, 0. And you'll notice that this one is a repeat. We don't have to write it twice. We're only going to write it once. So there are 3 intercepts, 0, 0, negative 2, 0, and 2, 0. That would be your answer for example 4. All right, up to you to try exercise 23. All right, let's talk about symmetry. Symmetry is if you get the exact same thing left and right or up and down, like looking in a mirror. All right, so this is an example of x-axis symmetry. If we drew a line right here, we would have a mirror image above and below that line. All right, and the line that we've drawn is on the x-axis, so this becomes x-axis symmetry. You'll notice here's an example of y-axis symmetry. All right, the mirror would go right down the middle vertically. And lastly, origin symmetry. I think origin symmetry is probably the trickiest for people to get. This is if you spun it in a circle, 180 degrees. All right, just flipped it both up and down and side to side, would you still get the same thing? So if we took this point here and flipped it vertically, it would end up here, right here. But then we're also going to flip it horizontally, so it ends up right here. And as long as that still ends up on the graph, we have origin symmetry. All right. So we can test for them geometrically by looking at them, or we can have some algebraic tests. So here we go. We have x-axis symmetry if y or negative y gets us the same thing. We'll do an example here in a second for this to make sense. We get y-axis symmetry if x and negative x is the same, and we have origin if both of them happen to happen. So let's try this. Let's test for symmetry on this one. Y equals 2x cubed. So we're going to start by doing, instead of y, we're going to go negative y equals 2x cubed. All right, so I substituted negative y for y. Okay, and so what we're checking for here is x-axis symmetry. All right, symmetry on the x-axis, we've switched the y for negative y. All right, let's get y by itself. So we're going to divide by negative 1, and we get y equals negative 2x cubed. Is this equation exactly the same as this equation? Okay, no, it's not because of the negative here. So we do not have x-axis symmetry. Let's try it with plugging in negative x instead. So second option here, y equals 2. Instead of x, we're going to plug in negative x cubed. All right? Now what happens if you cube a negative? It's still negative, so we have negative 2x cubed Is that the exact same thing as what we started with? No, it's not either. So we do not have y-axis symmetry. All right, so the last thing that we're going to try is origin symmetry, and that's where we replace both of them. Instead of y, we're going to plug in negative y. Instead of x, we're going to plug in negative x. And let's see what happens here. I'm going to clean up the right side first. Negative y equals, we know that we simplify down to negative 2x cubed. Let's get y by itself by dividing by negative 1. And so we're left with y equals 2x cubed, which is exactly the same thing as what we started with. So in this situation, in this example, we have origin symmetry. All right? Go ahead and run the test for yourself on exercise 33. All right, so sometimes symmetry can be helpful to sketch out our graphs. So in this one, x minus y squared equals 1. All right, so in this situation, I'm looking at this, and I know that I'm going to have x-axis symmetry because the y is going to get squared. So if I go x minus negative y squared, that's the same as x minus y squared, because when I square a negative, the negative goes away. And so this is exactly what I started with. So I know that my graph is going to be symmetric along the x-axis. So I only need to plot a few points to see what I'm going to get. So let's start. Oops, don't want a coordinate plane, I want a t-table. Let's start with a t-table. X and y. All right, and I'm going to plug in 0 for y to start. And I'm going to move the y squared to the other side to make this a little easier. All right, so if I plug in 0, 0 squared plus 1 is 1. So I know that 1 comma 0 is on the graph. What if I plug 1 in for y? 1 squared is 1, plus 1 is 2. So I'm going to have 2 comma 1. So 2 over 1 up. And since we know it's symmetric on the x-axis, I know that there's also going to be a point at 2 comma negative 1. All right, and so we could do one more. Let's plug in, how about 2 for our y? 2 squared is 4. 4 plus 1 is 5. So 3, 4, 5, and 2. And because we know about symmetry, there's also going to be 1 on the negative y side. So 5 comma negative 2. All right, so that's how symmetry can help us to sketch. Try 49, see if it'll help you. All right, let's talk about absolute value graphs. Absolute value graphs are V's. All right, they're going to look like this. So let's make sure we can come up with something like that here on 7. I'm going to flip back over to our graphing calculator and show you how to get the absolute value in there. So y equals, I'm going to clear this off, and it was absolute value, which is in math. So math, going to move on down to ABS for absolute. And there it is in the second option over. Absolute x minus 1. Okay. And let's check our window. Make sure our window's okay. It's not. Let's go with negative 10 to 10 again. And go ahead and graph it. And that looks pretty good. It's crossing just to the right of the y-axis. So we could sketch this coming in here. And if we zoom in, it is going to hit right at 1. All right, so there's our absolute value graph. Try 53. All right, circles. Circles we're dealing with here. So here's our equation for the standard form of a circle. X minus h, y minus k. All right, this should look fairly familiar from the distance formula. A squared plus b squared equals c squared. Okay, the only change here, h and k, is where the center is. So if we have a center on the origin, h and k are both zeros. All right, so we're going to use this formula to see if we can graph our circle. And also, I'm sorry, r is your radius, the distance from the center. All right? So we're going to try to write the standard form. So we have, let me write it in again, x minus h squared plus y minus k squared equals r squared. And let's plug some things in here. The point 3, 4 lies on this circle. 3 is an x value. 4 is a y value. The center is at -1. -1, the x value at my center is h. 2 is the y value at the center, so that's k. All right, and we need to figure out the radius. They don't tell us, but we could figure it out. 3 minus -1 is 4. 4 minus 2 is 2. That's 16. That's 4. That's 20. 20 equals r squared. All right, now you, first reaction is to square root that and get root 20, but we don't need to square root it because the formula is actually asking for r squared. So we're going to rewrite this and be done here. For any point on the circle is x plus 1, x minus -1, squared, plus y minus 2 squared equals 20. Okay, that's our standard form for this circle. We need to fill in values for the h value, the k value, and the r squared value. If we've done that, we've done it all. 73 is the one for you to try, exercise 73. All right, I believe this is the last problem here. Yes, number 9. All right, so 3 things we can do. Numerical, that's making a table. Graphical, that's using the graph, obviously, and algebraic, using the rules of algebra. So we're going to try all 3 here. All right, so we have this equation for the median recommended weight for min, all right, from 25 to 59 years old. So we have this equation. Let's construct a table of values first here for 62, 64. That sounds like kind of tedious to do it by hand, so I'm going to let the calculator help us. Let's go plug this in. Y equals, let me clear this off, 0.073 x squared minus 6.99x plus 289. All right, so we have that. There are some constraints in here. Okay, 62 is less than x is less than or equal to 76. And for now, let's just deal with those when we do our graphs. Okay, so we're going to say on here, we're going to use our table. But before we do that, let's do our table set. So second, table set, we want to set this up. So table start is where we start on our table. We want to start at 62. And it's saying 64, 66, 68, 70, 72, 74, 76. We're counting by 2 here. So let's go ahead, and the delta here stands for change. We want to change by 2's. All right, so let's go to our table, second graph, and boom, there's our answers. 62, 64, 66, 68, all the way down, all right, to 70. Oh, 76, we'd have to press down until we got it. All right, how about if we go ahead and do this, use the table of values to sketch a graph. All right, so we've already have this set up on here. So we could plot these out and connect them nicely, right? Or we could go ahead and go straight to our graph. But here in our window, we want to make sure our x's are appropriate. So let's see here, 62 to 76. And from our table, we knew that 62 had a value of 136. So let's make sure our smallest y value is a little bit less than that, 130. We knew from our table that the biggest y value is going to be 179. So what if we made it 190, just to be a little bit bigger than that? All right, so we have some space to look at it. We go ahead and graph it. And there we go, nice little curve on our graph. Okay. All right, and so lastly, use the model to confirm algebraically the estimate you found in part B. Well, we already have that, and it's confirmed for us. So you guys can plug that in. So C's kind of, we've already taken care of it. Alright, so 87, yours to try, and that should wrap things up. And so this one, there may be a few questions. If you don't fully get something, give it a try best you can, and then we'll go over it in class. Good luck.